Okay, welcome back to the stream. Today I'm going to be starting to work on like a resource economy system for the game, and it will probably be mostly programming. So one of the main ideas for this game is that every district has its own local economy where people are working jobs so they can make some money so they can buy resources which they need to survive. And the economy in this city is kind of like a zero-sum game where it's not like money is moving between countries. It's all staying here. So there'll probably be a finite amount of money, and it'll just circulate and change. Which district has what percentage of money will change over time, but the total money probably won't change. And at a high level, there's three different classes in the caste system: low district, middle district, upper district. And obviously the people in the lower district are going to be working jobs like farming and mining, and then the people in the middle district will be like military, maybe like weapons manufacturing, and like medicine or drug creation. So one of the ideas is there's a small chance that someone can get sick and in the lower district, and when they get sick they need to buy medicine to get better. But if they buy medicine, they probably can't afford food for a while, and if they can't afford food, they starve. And if something goes wrong in one district, the city's going to try to be sustainable and try to survive and bounce back. So if a lot of the population here dies, or they're no longer producing food, other people from other districts might come to this location and start helping with the food production. Because the idea is like the city's maximizing its like operating capabilities. Another idea I have is kind of like a trading post game where the buy price for, say, food in this district is dependent on how much food's available here at this location and how many people are hungry. So if there's a lot of food and no one's hungry, the buy price for food is probably pretty low. But if in this district there's not a lot of food being produced right now and people are starving, they'll be willing to pay a lot more for food because it's now like a life necessity. So you as the player or other characters in the game, like the AI, can try to maximize their profits. So they could maybe buy food from this district and then at a low price and then resell it here at a high price. And the same goes for medicine. I'm thinking like medicine will be very expensive and almost unaffordable in the lower districts. And maybe you as the player could start a disease after buying up all the medicine and then start a disease, some infection in one of the districts, and then all of a sudden the players in the simulation are willing to spend more on medicine because, one, it's not available, and two, a lot of people are getting sick. So those are kind of like the mechanics I'm thinking of, and this resource economy system will kind of be like the backbone for all this the characters' decision making. So they'll obviously have like their daily schedule routine system. They'll like go to sleep, eat food, walk from their apartment to their job, like all those systems but what's motivating them and how does the whole city like move and flow, I think will be dictated by this resource economy system. So I expect this will probably take like a month before it's ready. What I'm currently doing is not even worrying about the graphics and just programming it as like a text-based simulation, and then once I'm happy with that system, I'll integrate it with the existing like city location graph and the actual characters in the simulation. So probably not gonna be working for a bit on this like actual 3D game stuff, but instead just writing the code for the system. And one of the things that I'm somewhat inspired by, or like something I've done before, was in college I took a biology class, and we used this programming language called NetLogo, and it's like a really simple like agent-based programming system. And what it lets you do is easily, with like just a few lines of code, create these kind of like ecosystems with different starting seed values and different formulas, and you can kind of see like how populations do over time, and do a lot of type of like simulation stuff. So I'm not going to be using NetLogo. I'm going to still use Unity and C#, but I'm going to try to recreate some of this functionality. So what I currently have is really primitive. I spent like a couple hours this weekend after brainstorming with like a really simple text-based thing. So what that looks like, this code here is like my main function for the regular game. So this like initializes the like 3D part of the game. But I created like this folder, called it resource economy, and I created like a very simple economy simulation mono behavior, and I'll show you what that does. So what this does is all it's doing is printing some text to the screen, but it's saying this is day 0 of the simulation, and it's just printing some stuff. So we have the upper district, which is like this text. We have the middle district, and we have the lower district. And if I press the arrow keys on my keyboard, we can go forward one day. And we can see, like, for example, in the lower district, the current food buy price is 1. It costs 1 unit of money or whatever to buy a piece of food. And I know it's not really clear from this text display, but this is how much money a person has and how much food they have, as well as their current hunger. So if I keep going through the simulation, we can see the food buy price is going up, and the reason for this is this district is getting hungry. So this is like a probability. 0 means no one's hungry, or I guess this is a 0 to 1% of like what portion of the population is hungry. So if I press the arrow key again, it looks like people are buying food, and their money is slowly going down, but they haven't died yet. Like, they're able to survive. And it looks like on day 18, everyone died. But, and I'll just walk through the code really quickly. So mono behavior takes an input, lets you update the simulation one day. And the simulation is just like a C# class. So we create like a population. We create like a district graph, which is just a map of people to the district they're in. We create some a list of people. So we have like a person class, and person has like some let's see, what does the person have? So person right now has some basic properties like, are they sick, are they starving, how much money do they have, how much food do they have, how hungry are they, how many consecutive days they've been sick, and do they have any medicine. They also have like job types, and then like a reference, I guess, to the current district they're in. And then there's some functions or methods for updating the state of the person in a simulation. So we have population, we have a graph that maps people to districts, we have a class for a person, and what else do we have? We have an economy, it looks like. Oh, sorry, we actually have a district economy class. And what's a district economy? It looks like a district economy is kind of like a summary of like how the population in that district's doing, as well as like what resources are available for trading. So we have like available food and available medicine, and we have like functions to buy food and medicine, so like to do trading. So like buy food, takes in a person, checks if there's available food to buy in this district, if the person can afford to buy the food based on the current price. So a district economy can also set the price, and the current price is always a function. So very simple, just saying like, hey, between a minimum price of $1 and a maximum price of $3, scale based on how hungry people are. So as people in the district are more hungry, the price of food goes up. So how does get district hunger work? It's just a function where you, I guess, count how many people in the district that live there are have this starving Boolean set to true, and then you just divide by the total number of people. So this is, I guess, how hungry this district would be, which we can use to dynamically like calculate the price of food. So a district economy is just like, what's the economy for that local district and what's available. So we have that class, and then we have another class called economy, which is a list of district economies. So the overall economy for the city is just a list right now of district economies. And I commented this code out, but I'm kind of thinking like, I need somewhere to like start the initial pool of money. But like the overall economy should be able to tell us how much money is in the total game. So we might like sum up everything in the resource economy, like for the whole city. Super rough, messy code. Nothing's really like, a lot of this stuff can be like made into generic classes. So probably makes sense to have a resource class, and a resource class, has like a buy method, and rather than all these like variables just created for each resource. But this is kind of like super hacky proof of concept, get it working, and then slowly make it into a strong system. So one thing I noticed when I was just demoing this was we have this like, we take an input and we make the simulation go forward one day or one tick, and then we draw the simulation every frame. And right now, drawing the simulation is really simple. We just call this describe method on the simulation. And what describe method does is it tells us what the current day is as a string, and we append to that string a method call to the economy class. So we say an economy simulation is a description of this plus whatever this description is, and the economy's description is like some total economic stats, and then we iterate through the district economies that we have, and we append the description of each district, I guess. So it's like really basic way of just quickly trying to render what's happening without actually doing any graphics or anything too sophisticated. So let me just change this. Overall district hunger. Zero to 1 scale, because I was kind of confused by what that meant. And I also want to, so right now there's no variability between people. So rather than, if I have 100 people in the district, rather than me like printing out 100 people to the screen, which would use up a lot of screen real estate and not really work, I'm just using averages. So I'm just averaging all the people in the district. And right now an average is the same as like a single person's stats, because there's no variability yet. So I'll need to, obviously when I add some variability, fix that. But one thing I also want to print out is, I guess, like average, I guess, hunger or something. So let's just make a method like average hunger. This way I can not see it as a 0 to 1 scale. So money, food, medicine, then we'll say hunger. Okay, so I think that will look, hopefully that'll be easier to understand. So overall district hunger, 0 to 1 scale, money, food, medicine, hunger. Okay, cool. And just to clarify how the stats currently work, like the thresholds are set, is every day you lose 1 hunger, and if you are -5 hungry, you die. If you're -2 hungry, you are full, or sorry, that's when you start starving. And I'll probably also do like, let's see, max food. I don't know a good name for this variable yet, but like you cannot go above a fullness or a hunger of maybe like 2 or 3. Like it doesn't make sense that you could increase your food, your hunger stat. Like a person can't eat 100 days worth of food and then not starve in 3 days. It doesn't work like that. So basically people can't stock up on too much food and eat it. But I don't need this yet. So back to this. I think I'll have to restart the editor or the game. Okay, so if I go forward, people are getting hungry, and I think they're programmed once they start starving to eat. So let's see. Actually, it looks like if they lose one food every day, and they always eat if they're of negative hunger, if they can afford it. So this population's about to die, and the reason this middle class population died is this population doesn't have any food. There's no food produced there. Not that they can't afford it. Whereas here, we can see people are starting to get hungry, but they're also running out of money. So for the past few days, they didn't die because the people were producing food. So there was food available to buy in this district, but they've slowly lost money because it costs currently $3 to buy food, but they only make $2 a day. So they can only eat every other day with the current setup. So they just bought some food, so their hunger didn't go down that round. They can't buy food the next day, but they were able to make some money. Their hunger is now -3. So they'll buy some food. It won't go down. Money just went down. Hunger's, so yeah. And now they're all dead because there was food to buy, but they couldn't afford it. And that's not really like ideal for this game. Because I want it to be like sustainable. So if you, the player, try to like disrupt the economics, the city should kind of like self-correct. The economy should self-correct. Like people should move between districts if there's better opportunities, or people should try to like move resources around, supply and demand. So that's like background on what I'm going to be working on as this in the stream. So one of the first things I want to add is I want to be able to draw graphs, like not good graphs, just simple graphs, so I can see these values changing over time, because I think it's going to be really hard to like design and visualize and make sure the simulation is working correctly if all I see are these numbers. I really think I need graphs over time that show resources and population changing. So I want to be able to make something like this. Doesn't have to look this good, but I need to be able to do this. So the idea I currently have is, let's see, I have a very simple method, and again I'm using a line to do like drawing of lines and stuff. Highly recommend that package. And I created a really simple method that's like draw a line graph. Takes in list of points, an offset, so you can like position multiple graphs on the screen, some scaling value, a color, and then like a label for the graph. And very simple, just like draw the label to the screen, draw the points to the screen. And what that looks like is nothing great, but we have this really simple graph called test, and it's just like 3 points going up and down. So I'm going to use something like this to start creating these graphs. But what I need to do is I need to be able to capture metrics for these values. So these are all single values, and I need to store them, or at least be able to capture metrics every time. Let's see. Every time this like tick function is called, I want to be able to save uh, certain properties on the characters and like add a log a metric for them, and then using like a list of metrics, I can render new graphs so we can see the values change over time. So the idea I have is to just create like a metrics container or something, like a metrics class. Just call it metrics, and this be a pretty simple class, I think. And I'm not even going to bother making it generic at this time. Create a list. And we will support adding. And we'll support getting the list. So some of the metrics I want to capture right now are going to be in this person class. So it's getting hard to read because I put my variables in between functions or methods, which is kind of hard. Yeah, I did not follow any convention for anything in this class, it looks like. But so I'm going to create a metric for money. So call it I'll create one for food. As well as hunger. I think that'll be good for now. So in this tick function, after like all the logic is done and values have been updated, we are going to update our metrics or log metrics. Maybe we'll call it log. So pretty simple. Money. So now we can log metrics for people. We also want to log metrics for the district economy. So see what variables we have here. And I think I want a death metric. Available food metric. And let's see. People average food. Hunger and food and money. I don't think I'll use the people metrics actually yet, to be honest. All right. So in the tick function here, I'm gonna update all these metrics, each update of the simulation. So delete. .log and death count. Okay. So now we should have metrics that get updated every tick of the simulation. The next thing we have to do is draw the graphs for them. So can reuse this. but we need access to those metrics objects. We need to be able to get the metrics data. But all those references are private. Just gonna make public getters for these so we can step through. And access those metrics objects. Because I don't want to do work to preserve this encapsulation. At some point, I'm going to need to make districts have like identifiers or UUIDs so they can be referenced easily. I could also add a method here that gives back a graph object, which actually might be, or like a line graph object, which actually might be the best thing to do. Just like we have a describe method. So call it line chart. And right now, a line chart can have a name. And we'll also say like a metrics object. And here we can, this district economy can figure out what graphs or line charts it should return. So kind of moving some of the code into here. So we'll call this the available food graph, and we'll give it the available food metric. Just change the order. This. And since I don't have UUIDs or any type of ID for the district at this time, I'm just going to use the district type since I only have one of each district type. But in the future, when I have like 8 districts for each district type, I'll have to use some sort of like index or identifier that's unique. And we also want death count. Death count. Average hunger. Average money. I'm just going to add some colors to these as well. to help me understand or associate a color with a thing. Food metric. Call this there's no compile time constant for color. I always forget in C# how to have multiple constructors. Constructor syntax. This page is taking a while to load. Looks like we're having an issue with the stream. Huh. So it looks like multiple constructors. You have to use this colon, this, and then you can call another constructor. That works. Okay, so now we can get all these line charts from a district. So let's see. Economy, get. So now we want to draw these graphs. And I don't really care about performance for this right now, so I don't even care if I do this every frame. I can make it faster later. Let's see. J equals 0, J. So we go through all the districts, we get all the line charts, and we're going to have an offset, I think. So obviously we can't draw the graphs on top of each other. So I'm thinking for now, let's just, I'm gonna have to normalize the graph size later, but for now, let's just shift the graph over. So x will be j times, let's say, let's make some variables for this. Private const graph width. Just say 10, graph is 10 wide, and height is 5. So we're moving the horizontal right now, so that'd be j times graph width. I is going to be the vertical. So I'm thinking do -1 times I. So I want the graphs to go downwards. Graph height. So we have our offset, and now we can call draw line graph. Gonna make another method, takes in a line chart. And offset. So now we just need to be able to convert or adapt this class to this input. So we only have a list of integers, not vector2, which are like tuples, or two values per item in the list. So naturally, our metrics are currently increasing. The x is increasing by 1 every entry. So just doing this should work. Sometimes JetBrains Rider is smart enough to auto refactor this to a link expression, but it doesn't look like it's doing that here. This is fine though. So draw graphs, draw our graphs. I think this should work. Let's test it out. And we have some errors. So my first mistake is if we don't have any points to draw, we should not call this function. It's still not working. Oh, that's my bad. I also am using this to set the position of the graph. That's why. I think I'll just use offset here. Okay. So let's see what this looks like. So it's kind of small, but we have our graphs here. Oh God, it's way too small. So I need to increase the spacing for one. We're gonna have a base offset of minus 100, 0, 0. And let's maybe make this 500. And I might also scale the graphs down a bit. So we have this scale variable here. Say 0.25. So a quarter of the scale. And let's see what this looks like, if this looks any better. So now the labels don't line up with the graphs. Why is that? It's probably the scale. is looking better. The one thing I don't like is this label position. So I'm gonna change this code here. I'm gonna go back to drawing it. At the first graph position. Let's see what that looks like. This is super hacky. Like, this isn't like building a well-formatted graph system or anything like that. It's just so I can have some basic graphs and see what's going on. I think I want to normalize the y-axis as well. So to do that, I think create this variable called max value. We'll set it to 1. And here we can calculate the max value of the line chart. So we can say, I don't know how this will look, but max value I think I can use a link expression for this. Let's see. People that values dot. Okay. And if we just divide all our so defaulting to 1 means no normalization or scaling is applied, and then we only want to normalize this, so we'll just divide it by the max value. And ooh. It's not just doing this, we also want to multiply this normalized value by the graph height. I think that's what we want to do. And I broke everything. What happened? Probably the fact that these are integers. And what is this? What happened here? Graph height. This should be a float. Sequence contains no elements. Maybe you can't call max on an empty list. That might be why. Let's see. Yep, can't do this. Okay. So let's do greater than 0. Count. I still get not a number line coordinates. Huh. Is this even the issue? See what happens if I set this to 1. Okay, this, if that's 1, it works. There should always be a number between 0 and 1. And then you scale it by the graph height. What is this coming out to? Because this looks correct to me. Alright, I'm hoping this debug log statement helps me figure out why this is not a good number. Max value is 0. Normalize y. Oh, I see. This could be an empty list. So I need to always make sure this is at least 1. There we go. Okay. Still not looking good. There's definitely something wrong. And it's starting to get slow. For now, I'm just gonna turn this normalization off until I can figure it out. Something's not right still. And since it's getting slow, we need to cache some stuff. So we can't do this every frame, and there's really no point in doing it every frame. I know A-line has some caching stuff when I was reading the documentation, but before I look into their caching, I'm gonna at least cache up into this call. I can still make this call every frame for now, but this I want to cache. So I'm thinking super hacky way of caching. We'll just create dictionary. Key will be a string, and the value just look. I think this library has a feature for drawing things for a longer period of time using draw with duration. So draw with duration. What does this do? Do you call this from an update function? I wish the documentation showed whether you call this from an update function or a standalone function. Let's try it standalone. So now I'm only going to draw this. I'm only going to draw the graphs when something changes. and I'm hoping they stay on the screen for 2 seconds. Let's see. They do not. Okay. So I need to call this every frame. This definitely is faster. Seems faster. So yeah, this isn't perfect, but I feel like it's slightly better than nothing. So I can see trends over the simulation. I'll definitely have to keep working on this. But their hunger corresponds with death count. Their money keeps going up after they die. That doesn't seem correct. Try to fix that. So yeah, the district shouldn't be paying them if they're dead. And yep, so now when death count goes up, the money does not increase at all. And also looks like we stopped collecting metrics. If they're dead, we return. It's the problem with having messy code, where there's two systems modifying people. So the district economy pays the person, but it shouldn't pay them if they're dead, meaning honestly this should be more sophisticated. But we still want to log metrics for the person, even if they're dead. Cool, now I have like the flat line effect. Alright, thanks for watching the stream. That's all I'm going to do tonight. It's 12:14 in my time zone. But yeah, I'll keep working on this in the next stream, and I think next I want to work on adding some like dynamicism between the districts. So right now all the districts are isolated, but I want to start having resources across these district economies starting to like exchange with one another based on the current like prices of the resources in that district.